be eating. All right, so on the count of 3, 1, 2, and 6. 1, 2, 3.
I can solve for a logarithmic equation with a natural log.
All right, now tables 1 and 2. Because I didn't hear tables 1 or 2. We'll get it down to just 1 if we need to. All right, on the count of 3. 1, 2, 3. All right, do you want me to just call on you all? Because I can call on you all and have you each read it out individually. Okay. All right, so one more time for tables 1 and 2. You guys used to be as good as the BC class, but you've lost it. First period's better. All right, they're asleep. All right, so tables 1 and 2 on the count of 3. 1, 2, 3. All right. Let's do, so we're going to come down to, we were working on example. We should be up to example number 10. So this is our blue heart examples right here. Okay. So if you're coding with me, those are blue heart ones. Okay. All right. So if you have out in the left-hand column an E, okay. So if you have an E, you take the natural log of both sides. So E and natural log go really well together. We learned earlier in the unit that it's not the proper, they're inverses of each other. So we'll say they cancel each other out. Okay. Natural log. Yes. Okay. All right. So looking at example 10. Notice I have an E in the problem. So when I have an E in the problem, first I have to isolate it. I get it by itself, which it already is. Okay. And whatever I do to the left side, I have to do to the right side. So on Friday, we were logging both sides. When there's an E instead of logging, we natural log both sides. So I'm going to take the natural log of both sides. All right. So what happens with the natural log and the E? They cancel. So we've got 2x equals the natural log of 6. Okay. And then I got to get the x by itself. This is a number. How do I get this number to the other side? Divide it. So the natural log of 6 divided by 2. All right, so we're now going to go ahead and use our calculator. So remember, if they ask for exact value, I would stop. If we don't ask for exact value, we want you to use your calculator. So we're going to go to Desmos. So everybody get to Desmos for me. You have to learn to put this in. All right, so the natural log of, where were we at? I lost it. 6 divided by 2. I'm probably going to put parentheses around this so I can hit the divided by. Natural log of 6 divided by 2. If I don't put the parentheses, notice it turns it into 6 divided by 2 inside the natural log. The answer is different. So we want that first answer. So 0.89, and what would I round this to? 6. So 0.896. 0.896. Okay. Now, on example 11, notice how there's a coefficient in front of the E. I have to move that first before I can natural log both sides. So how do I move the 9? Divide it. So 1 divided by 9. All right, now I have an E. I don't know how to solve for that. What do I need to do to both sides? Natural log both sides. So natural log of e to the x equals natural log of 1 over 9. What happens with the e and the natural log? Cancel. So I get x equals the natural log of 1/9. Okay, everybody put it in your calculators for me, please. Okay, so everybody's doing that for me. All right. What did we end up with? Negative 2 point, what was it? 597? 197. Everybody agree? Everybody got it in the Desmos? Okay. All right. You have to be able to put it in Desmos. I don't know. Let's look. Natural log of 1 divided by 9 because it came up negative. Okay. Everybody good? All right. All right. Let's take a look at. Okay. So we're going to go to another thing. So this is a different colored heart. So let's go back up to the top and let's look at it. Okay. All right. So this one is going to be the green heart. So right now, I just want you to read the green heart to yourself in your mind. Okay. So read the green heart in your mind. Okay. I am going to read part of it, and when I pause, you read the next word. We'll see if this works, okay? All right? You ready? I want you to read just the next word, not anything beyond the next word, okay? So, I can solve a... Okay, I want to hear everybody, so I'm going to do it again. I want to hear... you used to be able to do this. Really good. Okay. All right, so I can solve a equation with a log on one side, good, where I have to it to form or using a log loop. We've actually kind of done this already, but we're going to make it more complicated. Okay, so this is using our log loop to solve for a log, not just to do the conversion process. Okay, all right. So let's go to these. So these ones starting with example 12 are green heart problems. Okay, so my green heart is right there. All right, in the left-hand column. Okay, so this is kind of, again, instructions. So when you forget, you can go back and look. Okay. So if you have one log on one side of the equal sign, then we're going to use what Mrs. Ballard calls the log loop. Mrs. Rondeau calls it something different. Miss Hanby has her name for it. I call it the log loop. Okay. So I'm looking at the problem. Okay. I see one log on one side. Okay. So that means I'm going to do the log loop. All right. What is my base? 8. Okay. And then I'm going to switch the location. So I have 8 to the x equals 512. All right. Hopefully it's one of the things on my chart. Okay, so go look at the square and the cube chart. What do you notice? What's another name for 512? 8, not squared, but cubed. Good. Did I get my bases the same? We learned last week the bases are the same, they cancel. And so our x would equal 3. Okay. They're not always like that, right? I could show you 100 different problems today. That's why this lesson is so long, and I still not hit them all, okay? So you have to just learn the rules and kind of keep following the rules, okay? All right, notice on example 13, one log, one side. So I'm going to log loop it, all right? What's my base? 2, and then I'm going to loop this around. What's going to be my new exponent? 2 to the 9th equals x. All right, put it into Desmos if you need to. I know that's not one of the ones we normally memorized. What do we end up with? What is it? Oh, it's 512. I didn't do that on purpose. I actually took the problems right out of Delta Math. So, all right, so we ended up with 512. Any questions so far? All right, everybody try 14 on your own. You try 14. Okay. What is your base? 2. And then I'm going to loop it again because I have one log on each side, one log on one side. What's my new exponent become? X equals 4. What's another name for 4? 2 squared. So my bases are the same, so X ends up equaling 2. Okay. All right, let's take a look at 15. Okay, we're amping it up a little bit. We put a fraction in there. All right, what's the base on 15? 49, and then I'm looping this around. What's my exponent? 1/2 equals X. All right, 49 to the 1/2 power. Remember the 1/2 power symbolizes a square root, right? I could rewrite that as the square root of 49, right? I take that 2, it goes out in the index. I don't have to write it if it's a squared and has an exponent of 1. What's the square root of 49? 7. Okay, so it's a fancy way of asking you to find the square root of 49. Okay, let's take a look at 16. Okay, so again, one log on one side. All right, so what is my base? 7. I'm going to do the loop. What's my new exponent? -2 equals X. All right. Is my, whatchamacallit? X, what do I not like about that exponent? It's negative. So is he happy where he's at? Now I've got to bring it downstairs. So I go 1/7 squared equals X. What's 7 squared? 49. All right. Everybody try 17. Okay. All right. I want you to check it with your table partner real quick. All right. What's the base? 64. Okay, I'm going to loop it around. What's my new exponent? 1/2 equals X. It's a fancy way of saying the square root of 64 equals X. What's the square root of 64? 8. Okay. You may see some cube roots too. Okay. So, all right. We're going to make this a little bit harder. Same things. These are still going to be whatever we're on. We're on greens or green heart problems. So there's still green heart problems. They're just a little bit more complicated. Okay. So, actually, take that back. Let me look up there. Let me go back and look. It might be I need to do. Oh, no, they're not. We're moving on. These are purple heart problems. Okay, so really quickly, read the purple heart statement to yourself. Okay? Read the purple heart statement to yourself. All right. I'm going to read, and when I pause, you read the next word. You ready? I can solve a equation with 2 logs on side of the equation. Okay. All right. So we're going to label these next few with the purple heart. Okay. Again, similar. We're going to add to what we were doing just a little bit. Okay. If you have 2 logs on one side of the equal sign, then you condense first and then use the log loop. So we're going to use, again, some of the skills we learned in the first part of the unit. We're going to condense our logarithms together. So we're going to turn addition into multiplication, subtraction into division, And then we're going to use our log loop because we'll be down to 1 log on one side. Okay. All right. So looking at this first one, I have addition. What does addition? Actually, I can't do that quite yet. Before I can do that, I have to take and I have to move this guy up. How do I move? Where do I put the 2? Exponent. So that's not new. We've been working on that for a while. So I'm keeping it log base 2 of 2x plus log base 2 of 8 squared equals 2. All right. I could do this in 2 steps, or I could do it in 1 step or 2. I'm going to do it in 1 step. Okay. So I'm going to do a little bit of work in my head. All right. What does addition turn into? Multiplication. So remember, this is where I condense it to 1 log. Okay. So I'm going to multiply 2x by, what's 8 squared? 64. Good. Equals 2. I'm going to go ahead and simplify that before I try to do any looping. Okay. What's 2x times 64? 128x equals 2. Good. All right, notice I'm now looks like the problems we had up here, right? 1 log on one side. So what is my base now? 2. And I'm going to loop it around. So 2 to the what power? 2 equals 128x. Now it's algebra 1. All right, what's 2 squared? 4. Good. Okay. What do I have to do to move the 128 to the other side? Right now it's multiply. How do I move it? Divide. Good. All right, and then I could reduce that fraction. How many times does 4 go into 12? 3 and into 8? 2. So 1 over 32. And it's okay to leave it like that. You don't have to go decimal. There's no rule that says you have to. Okay. I kind of like that better, actually. All right, we're going to try it again. Okay. So I don't have any little coefficients in front, so I got to check for that first. So I don't need to move any exponents up. What does subtraction turn into? Division. So log base 2 of 8x over 7 equals 4. All right. I have 1 log on one side, so now I need to log loop. What's my base? 2. And then I'm going to loop this around. So what's my new exponent going to be? 4 equals 8x over 7. What's 2 to the 4th? 16. Now, I'm going to rewrite it as 8/7 x. It's the same thing. How do I take that 8/7 and get it to the other side? Right now it's under multiply. Divide. But if I divide, I'm dividing by a fraction, right? If I divide by a fraction, that's same as multiplying by its what? Yeah, so I'm going to multiply by its reciprocal, right? I'm technically doing it over here too, and it crosses things out. I don't usually write it down on the right side. I only write it down, or whatever side I'm moving it from. I only write it on that other side. Okay, so how many times does 8 go into 16? Twice. So what's 7 times 2? 14. Good. Okay. All right. Let's see what the next ones look like. Oh, more of the same. Okay. All right. I'm going to fill in the little blank on the left, and then this is similar type of problem, but there's one thing that might pop up in here. It probably doesn't pop up till 21, but I want to make sure we've got it just in case. So make sure you check to make sure your answer does not make the inside of a log negative. So it's okay, like on the first examples where we had no logs in the problem, we were taking the log of both sides, it's okay to get a negative answer there. I'm not allowed to put a negative answer back inside a logarithm. On these first few here, we weren't getting any negative answers, so they were fine. We didn't need to check it, but we really should have been checking it. Okay. All right. So I want you to try example 20. It's very similar to example, the one right above it, 18. Okay. So everybody's going to take a minute and try 20 from beginning to end on your own. Make sure you condense first. All of it after 18. Okay, we're going to take a look. Okay, so the very first thing I do is I see a number in front. Where is that going to land? Exponent. Good. So we've got log base 2 of 3x plus log base 2 of 4 to the 4th equals 2. Okay. What does addition turn into, everybody? Multiplication. So I've got log base 2 of 3x times, I'm going to go ahead and do this. What's 4 to the 4th? What'd you guys get? 256. At the same step, could I have done the 256 times the 3 and done that all in one line? That's okay. If you're using a calculator, you want to do that, that's fine. Okay, help me out because I didn't do the math. What's 3 times 256? What'd you get? 768x equals 2. Okay, again, I stole the problems out of Delta Math. So you can see at least we're getting some practice with what Delta Math's going to throw at you, right? All right, sometimes I pick and the numbers are way too easy compared to theirs. All right, what's my base? 2. So I've got to loop it because I have one log on one side. So what's my new exponent? 2. So 2 squared, right, equals 768x. All right, what's 2 squared? 4 equals 768x. All right, I got to move the 768 over. All right, let's see it. I'm curious how this comes out in Desmos, actually, because I want to show you a Desmos trick if I can. 4 divided by, it was 768, right? All right, did you ever see this little button over here to the left? Let's say your answer wasn't decimal, it was a fraction. Do you see how it just reduced the fraction for you? So all you have to do, if it comes up decimal, hit the little fraction button and you can get the fraction. Does that make sense? Okay. Because sometimes, what if it was like a multiple choice and I didn't give you the decimal, you had the fractions? That's a nice quick way to do it rather than having to divide them all out. So x equals 1 over, was it 192? Is that right? Yeah. Okay. Or at the decimal point, that's fine. Give me a minute, okay? All right. So let's take a look at number 21 here. Okay. All right. So it's the same thing. I've got 2 logs on one side. So I'm going to start, but it's a little bit more complicated on the inside, right? So what is my base? I'm sorry, I don't want to do that yet. I have subtraction. What does that want to turn into? Divide. So I've got log base 6 of x squared minus 4 over 2x plus 4 equals 0. Okay, one log, one side, log loop, right? What's my base? 6. Okay, now I'm looping this around. What's going to become my exponent? 0 equals this big mess, right? The big giant mess. All right. What is 6 to the 0 power? Anything to the 0 power is 1. Okay. All right. I've got to get, this is right now under division. How do I get it to the other side? Multiply. So 1 times that is just this thing here, right? 2x plus 4. Okay. When I have a squared like that, isn't that a quadratic? How many answers am I going to get? 2. When it's a quadratic, what do we have to be equal to solve it? So you see how that just popped back into our lives again, right? So all of a sudden, we're back into magic X and quadratics, and it rears its ugly head again, okay? All right, I've got to move the 2x to the other side. How do I do that? Subtract. So I've got x squared minus 2x, and then how do I move this 4 over? Also subtract. So 4 minus 4 is 8. Okay. What do I have 3 terms? What kind of factoring do I do? Good old magic X. If you don't know it now, oh my gosh. Right? All right, 2 numbers that multiply to -8 and add to -2. So we get 0 equals x minus 4 times x. This is the never-ending problem, right? It just keeps going. I'll give you a chance to... Okay. We're going to use good old zero product property, ZPP, right? All right. What am I going to do to move the 4 to the other side? Add it. What am I going to do to move the 2? Subtract it. Okay, now, I'm going to actually write it down, and then we're going to talk about our extraneous solutions. It's right there already. Where? I've got a lot of them today. Okay, you can go. All right. So we have to be careful because remember we just said out here in the left-hand column, we can't have a negative answer inside. So I really need to test my answers, okay? So I'm looking at this 4. If I put a 4 into x squared, is it going to make this term negative? So it'd be 16 minus 4. Is that okay? Yes, that's okay. All right. If I put the 4 into here, that would give me 8 plus 4. Is that okay? Yes. Okay. I'm sorry. Yeah, 8 plus 4. All right. And then now I'm going to test the -2 in. Okay. -2 squared would be 4 minus 4. Is it positive? Is it negative? It's 0, so I'm not worried about it, but it's not negative. Okay. All right, and then this one would be, it's still -2. So -2 times 2 is -4 plus 4. Is that negative? No. So those are both good answers. So these both check out and are okay. Make sure it's not negative on the inside. I'm sure we'll probably, one of these we might run across one. Okay, so you can see it happening. Okay. All right, let's see. We're at 22. Okay, we still got some time. All right. So let's try another one together a little faster. Gave you lots of space to write, didn't I? Look at that. Okay. We still have 2 logs on one side. What do I need to do first? Condense it, right? Are there any coefficients in front I got to worry about? No. Okay. What does addition turn into? Multiplication. So log base 3 of 3x minus 2 times 3x minus 2. Interesting. All right. I have a binomial times a binomial. What algebra do I need to do there? I've got a FOIL. Could I have done the foiling in this first step here? You could have totally if you wanted to. Okay. If you're the person that needs to see it written out like that, then write it out. Okay. All right. So I've got log base 3 Okay. Of, what's 3x times 3x? 9x squared. What's 3x times negative 2? And I'm going to have 2 of those, right? Because the inside's going to come out to be the same. So what's my middle become? And then negative 2 times negative 2. Good. I'm going to bring that up just a touch so you can see it better. All right. It looks crazy compared to what we had before, right? Think about how simple we started this and we really built it up. All right. I've got 1 log on one side, log loop. What's my base? 3. What's going to become my new exponent? 2 equals 9x squared minus 12x plus 4. All right. Now I have to square the 3. What's 3 squared? 9. Okay, do I have a quadratic again? Yeah, what do I have to get a quadratic equal to solve it? 0. Okay, so I got to move the 9 to the other side. How do I move the 9 to the other side? Subtract it. So what's 4 minus 9? Negative 5. All right, this one's super ugly, isn't it? All right, make sure we're caught up here. Give you a couple more seconds. All right, first thing I always look for is a greatest common factor. Do we have a greatest common factor? Not so lucky, right? Okay, when I have a trinomial like that, how do I start it? Magic X, right? Okay, so 2 numbers that we have to multiply these 2 together, so I get negative 45 and negative 12. So I need 2 numbers that multiply to negative 45 and add to negative 12. What times what's 45? 9 and 5. Are we going to get 12 out of those? Okay, what else? 15 and 3. Can we get 12 out of those? Negative 15, positive 3. You guys, that 15 times 3 comes up quite a bit. That's a good one to know. I know we've got our multiplication tables memorized, but that's another one to kind of add to the repertoire. Okay. All right. Do I need a box? Why do we need a box? It's been a while since we've done a box, right? We've got that leading coefficient. We definitely need that box. So inside of all these problems, we're reviewing all of our old quadratic stuff. That's what makes algebra so hard, is the process. It seems like it never ends, right? We have a problem within a problem within a problem. Okay. All right. What times what is 9x squared? 3x. Okay, so let's try 3x. Does 3 divide both of these? Yeah, so let's keep the 3x, x, and 3x on the sides. I'm trying to erase. Okay. What times 3x is negative 15x? Or how many times does 3x divide negative 15x? Just 5? Negative 5. What times 3x is 3x? 1, and then check it. 1 times negative 5 is negative 5. We'll still have to do lots of space, right? All right, so you have 3x, 0 equals 3x minus 5 times 3x plus 1. It doesn't matter what order you write those. Okay, what property do we need to apply? Nope. Zero product. If we foiled, wouldn't I just go back to what I just did? Right? So I'm trying to solve this. I want to use the zero product property, which says we're going to set these both equal to each other. Or sorry, equal to, not each other, equal to 0. All right. How do I move the 5 to the other side? Add, and then what do I do with the 3? Divide, so 5/3. Glad I used the delta math problems. I don't know if I would have made it this level of difficulty. All right, what am I going to do to move the 1 to the other side? Subtract, and then we get divide by 3, so negative 1/3. So get that far, and then we got to check them real quick. Okay. Okay, so I'm looking back at my original problem. Okay, so I'm trying to squeeze it all in there. There we go. There's my original. Okay. So if I take 5/3 and I plug it into there, let me think about that. So 3 times 5/3 would just be 5. Is 5 minus 2 positive or negative? Positive. Okay, let's think about this one. 5, and again, 5, it was the same thing, 5 minus 2. So 5 minus, or the 5/3 works, right? Now I'm going to plug in negative 1/3. So let's think about what that looks like. So it is 3 times negative 1/3. The 3's are going to cancel. I get a negative 1. What's negative 1 and negative 2? Am I allowed to have a negative inside? Do you see how it created a negative inside once I plugged it back in? So this answer right here is extraneous. Okay. All right, I think we've had it for today. I know I have. Okay. So we're going to stop there. 23 is very similar to 22. Okay. I'm not super worried about us getting there. So we will probably pick up with 24 tomorrow, maybe. But we're also going to re-looking at our quiz corrections so we can get that last quiz re-quizzed before the end of the triad, right? Because the triad ends on Friday. What's wrong? Oh, yeah. Is that good?